Okay, now this problem is a little bit different. It's actually quite easy to do because your calculator can do pretty much it all for you. Unfortunately, on a calculus test you have to show your work. So you are trying to find the equation of the tangent at a particular point. So in this situation it says write the equation of the tangent to a curve y is equal to x squared minus 6x minus 2 at the point 7 and 5. Now, if you bring your calculator up and you put your equation in, remember that we can get that to draw, and we might have to just change our, get it to draw something reasonable. And you know that you can, I'm going to have to go back up in here and turn the differentiation on. Okay. Back to the menu, draw the graph. Right, now go to Shift, Sketch, and ask it to draw a tangent. Now, where do we want that tangent? We want it to be at 7 and 5. So we only need the x coordinate. We say x is 7. Now you look. This, y is equal to 8x minus 51, is actually the answer to this question. So there it is. You can get it instantaneously. Unfortunately, we can't use that method to find this on a calculus test. We have to work it out. So how are we going to work it out? Remember that what we're talking about here is, again, if you're confused about what you're trying to do, draw yourself a picture. We have a quadratic. We have an actual point on that quadratic, 7 and 5. And what we want to do is we've got a tangent going to that particular point. So that tangent tells us what the gradient is and so on, but we want the entire equation of that tangent line. So remember that it's 8x minus 51? Well, how did we get that? How did the calculator do that? How did it get that? So remember that a tangent is associated with gradient. So how do we get the gradient at that particular point? Well, guess what? We differentiate. And when we differentiate that expression, we get 2x minus 6. Now, remember what this is. This is my gradient function. It tells me what the gradient is at any particular point. Since I've got a point, if I stick that point, this, remember 7 and 5, if I take that x and I stick it in here, 2 times 7 minus 6, which is 14 minus 6, which is 8. What is that? Well, that's the gradient. That is the gradient of, at that particular point. The gradient is a rate of change. And at that particular point, 7 and 5, that tangent, this tangent over here, has a gradient of 8. Now remember, the tangent is a straight line, so it takes this basic form. Well, I know this much of it right now. I know that this is this. I know it has a gradient of 8. I need the y-intercept. How do I get the y-intercept? Simply use that point that you know and stick it in. So this is y, 5 is y, so I have 5 is equal to 8 come on, you can do it, 8 times 7 plus b. And that's 5 is equal to 56 plus b, so b is negative 51. So we have just done what our calculator did, but we had to show all the work. So the equation of the tangent is 8x minus 51. We can prove it with our calculator, and we can check it with our calculator, but we've got to show the work. So you have to differentiate first, then you've got to find the gradient second, then you've got to stick that into your equation and finish off the equation by using your point.